For thousands of years, fire has been used to improve our lifestyles, but it has always been an uneasy partnership. As one of the most powerful elements to be harnessed by industry, fire has been a key to the development of our civilization. However, its capability for destruction is just as powerful and should never be underestimated. Along with the benefits of fire has come the need to develop the equipment and the methods for fighting and controlling fires. Most fires have one thing in common: they start small. And when a fire is small, it gives us our best opportunity to utilise the available firefighting equipment and extinguish the fire before extensive damage or injuries occur. But this is not as easy as it sounds. Unless you are familiar with how to use different types of fire extinguishers and are able to select the appropriate extinguisher to use, you'll not be able to safely or confidently extinguish a fire using a portable fire extinguisher. So, let's start and see how we can stop fires by first looking at the fire itself. Fire is a chemical reaction known as combustion. In simple scientific terms, it is the rapid oxidation of combustible material that releases energy in the form of light and heat. Geometrically, it is represented by a triangular pyramid known as the fire tetrahedron, the four sides representing heat, oxygen, fuel, and the chemical chain reaction. In simple terms, a fire needs the right combination of heat, oxygen, and fuel to start and continue to burn. The fuel is heated and gives off vapours. These vapours ignite, and the flames cause the chain reaction to begin. The chemical chain reaction commences very early in the burning process, and as it increases in intensity, it accelerates the rate of combustion. An understanding of this simple process, as represented by the fire tetrahedron, is all we need to know to understand the principles behind all firefighting techniques. Firefighting techniques are based on removing from a fire one or more of the four elements that combine to make up a fire. Simply, if we remove one of the components, we will not have the necessary ingredients for the fire to be sustained. The best way to understand this is to replace the components of the fire tetrahedron with the corresponding firefighting technique. Fuel is replaced by starvation. Starvation is the removal of the fuel from the vicinity of the fire. Remove the fuel and the fire goes out. Oxygen is replaced by smothering. A fire needs oxygen to burn. Smothering is the removal of oxygen available to the fire. This can often be done very simply. The same result can be achieved by applying an extinguishing agent, like we can see here. Decrease the level of oxygen enough and the fire will go out. Heat is replaced by cooling. Cooling is the reduction in temperature to a point that is below the level required for combustion. Lower the heat enough and the fire will go out. The chemical chain reaction is replaced by stopping the chemical chain reaction. A range of extinguishing agents have been developed which, when applied to a fire, prevent or interrupt the chemical chain reaction. Again, no reaction, no fire. So in summary, there are four techniques that are used to stop fires: starvation, smothering, cooling, and stopping the chemical chain reaction. And, in practice, it is often a combination of these techniques that is used to extinguish fires. Now, with the exception of starvation, that is removing the source of the fuel from the fire, each of the other methods of firefighting can be achieved by applying an extinguishing agent to the fire, usually by using a portable fire extinguisher. So, let's look at the common extinguishing agents. There are four commonly used extinguishing agents: water, foam, carbon dioxide, and dry chemical powders. Because of its availability and low cost, water is the most commonly used extinguishing agent. It works on the principle of cooling. and its effectiveness is due to its ability to absorb heat from both the burning fuel and the heated vapour. Firefighting foam was developed to use on flammable liquid fires. The foam forms a covering layer on the surface of a liquid, thus denying the fire oxygen. And because 90% of firefighting foam is water, foam also reduces temperature. Foam therefore employs both the smothering and cooling principles. Carbon dioxide also works on the principle of smothering. It replaces oxygen available to the fire with carbon dioxide. For this reason, carbon dioxide should only be used in well-ventilated areas, as it can be dangerous to human life. Powders react with a fire in two ways. First, they interfere with a chemical chain reaction, and second, they work on the principle of smothering by coating and forming a residue which excludes oxygen. These chemicals are often used as extinguishing agents on electrical fires, as they have the added advantage of not conducting electricity, unlike water and foam. Now, as we've said, all these extinguishing agents can be delivered to a fire by using a fire extinguisher. But how do we know which extinguisher to use on which fire? Different fire extinguishers are used for different types of fires, and most extinguishers can be used on more than one class or type of fire. The main exception being the water extinguisher, which is only suitable for fires involving ordinary combustible materials such as paper, wood and plastic. It's important to become familiar with the extinguishers that you may be required to use and know which classes of fire they can be used on. Fire extinguishers are distinguishable by both their labelling and their colouring. The current standard requires all extinguishers to be red, with different types of extinguishers marked with different coloured bands. The water extinguisher is all red. The foam extinguisher is red with a blue band. The dry powder extinguisher is red with a white band. The carbon dioxide, red with a black band. The wet chemical is red with an oatmeal coloured band. And finally, the vaporising liquid extinguisher is red with a yellow band. The labels on the extinguishers also give you further information. They identify the contents of the extinguisher, and they also give you operating instructions, but most importantly, they display pictographs. These pictographs indicate which type or types of fires can be extinguished with each particular extinguisher, and which fires should not be extinguished. These pictographs are used to represent different classes of fire. There are 6 different classes represented by the letters A, B, C, D, E, and F. Class A fires are fires that involve ordinary combustible material, such as paper, wood, and plastics, and are represented by this pictograph. Class B fires are fires involving flammable and combustible liquids, and are represented by this pictograph. Class C fires are fires involving flammable gases, and are represented by this pictograph. Class D fires are fires involving combustible metals and are represented by this pictograph. Class E fires are fires involving electrically energised equipment and are represented by this pictograph. And Class F fires are fires involving cooking fats and oils and are represented by this pictograph. As an example, with this extinguisher, you can see from the label that it's suitable to use on flammable liquid fires, but not suitable for use on fires involving electrically energised equipment. As a final point on the identification of extinguishers, you should be aware that there are still extinguishers in use that were manufactured before the current standard was introduced. This shows you the current extinguishers on top, and below in the corresponding positions are extinguishers with the previous colour requirements. The important message here is to become familiar with the extinguishers in your work area. Now, before we look at the different techniques that should be used when using different types of extinguishers, there are a couple of simple checks that should be carried out before using any extinguisher. Most extinguishers, with the exception of carbon dioxide extinguishers, have a gauge, and this should be checked to see if the extinguisher is fully charged. And before approaching a fire, you should remove the safety pin and test the operation to check the discharge range of the extinguisher. Now, let's look at how we should use 4 different types of extinguishers. First, we'll start with the water extinguisher. The water extinguisher is only suitable for use on Class A fires. That is, fires that involve ordinary combustibles, such as wood, paper, fabric, and plastic. The water stream should be directed at the base of the flames, working from side to side. As the flames diminish, you should change the stream to a spray by placing your finger over the nozzle. A spray is more effective in reducing the temperature of embers. When you've controlled the fire, separate the pieces and dampen down the hot spots to ensure that the fire is completely out. The next extinguisher we will look at is the foam extinguisher. The foam extinguisher is suitable for use on 2 different classes of fires, both A-class, that is, fires involving ordinary combustibles, and B-class fires. B-class fires are fires involving flammable liquids. The most common use of foam extinguishers is with flammable liquids, so let's look at how foam is applied to flammable liquid fires. First, if we have a contained liquid fire, as we can see here, the foam stream should be directed against the side wall and a blanket of foam allowed to spread out over the surface of the liquid. If this is not practical, the foam can be applied gently to the surface of the liquid and allowed to form a blanket. If the blanket is disturbed, momentarily direct the stream away and allow the blanket to reform. If in the event that the flammable liquid is uncontained, the stream of foam should be directed above the area and the foam allowed to drop on the surface. Foam can also be used on spills of flammable liquids to prevent fires. The foam stops ignition by preventing the release of vapours. It is also important to note that the foam extinguisher has a number of air holes located on the nozzle to facilitate operation. These should not be obstructed during use, as the expansion and the effectiveness of the foam will be diminished. The next extinguisher we will look at is the carbon dioxide extinguisher. This extinguisher is especially suitable for use on fires involving a live electrical source, that is Class E fires, but can also be used on Class A, B, and C fires. When using a carbon dioxide extinguisher on an electrical fire, you should direct the carbon dioxide discharge at the source of the flames. Also, whenever it is safe to do so, you should turn off the power to the equipment involved, or the fire may reignite. The horn of the carbon dioxide extinguisher also requires special attention. It can cause freeze burns if touched during or after use. The final extinguisher that we will look at in detail is the powder extinguisher. This type of extinguisher is often suitable for use on Class A, B, and C type fires, and also for use on fires involving a live electrical source, or Class E fires. Some powder extinguishers are not suitable for fires involving ordinary combustibles, or Class A fires. Remember to check the pictographs on the label. The basic technique for use of this extinguisher is to aim the discharge at the base of the fire, sweeping back and forth slowly at first, and then increasing the speed of the sweep as you move in on the fire. When applying the agent to a Class B flammable liquid fire, care should be taken to avoid splashing the flaming liquid out of the initial fire area. Also, you should be aware of the possibility of re-flash if the fire is not completely extinguished. When using a powder extinguisher on a Class A fire, that is a fire involving ordinary combustibles, you'll need to break up the fire after you control it and coat the hot spots. Dry chemical agents don't cool the fire. They work by coating the combustible materials and forming a residue which smothers the fire. Powder extinguishers are quite effective for use on electrical fires, but because of the mess they create, they are not ideal for use on equipment that contains electronic components because of the collateral damage that may occur. More suitable for fires in clean rooms, computer rooms, laboratories and similar areas are CO2 extinguishers or vaporizing liquid extinguishers. Now, we obviously haven't covered every type of extinguisher, or for that matter, looked at all the different types of extinguishing agents that are currently available. However, we have looked at some common examples with extinguishers that are widely used. Again, the important message here is to get familiar with the extinguishers that are in your workplace. Learn which extinguishers are suitable for which types of fires. And if you have any doubts about how to operate or use any particular extinguisher, make sure that you speak with the appropriate person in your organisation. Finally, before using any portable fire extinguisher, there are a few basic guidelines that should be adhered to. Before approaching a fire, always turn in an alarm first. If possible, don't fight the fire alone. Always make sure you have an unobstructed exit path. If the fire is outdoors, you should approach the fire with the wind behind your back. After testing the discharge range of the extinguisher, be sure to get only as close as necessary to extinguish the fire. When in doubt, stay back. Once used, never return the extinguisher to its original location where it could be mistaken for a fully charged extinguisher. And most importantly of all, after raising the alarm, only approach a fire and use a fire extinguisher if it is safe to do so. If you are in any doubt, do not fight the fire. Prevent small fires becoming serious by becoming familiar with the firefighting equipment available in your workplace. Know where it is located and how to use it. Being prepared for the possibility of a fire occurring will dramatically increase the chances that it will be controlled both quickly and safely.